Please pause the video and try this question. All right, let's take a look. If n is a positive integer and the product of all integers from 1 to n. Product of all integers from 1 to n is actually nothing but n factorial. What about this product? Inclusive, what about this product? The product is a multiple of 990. What do we have so far? N is a positive integer and n factorial is a multiple of 990. What does that mean? N factorial can be written as 990 times k, where k is an integer. What is the least possible value of k? What's the least possible value? How do we figure out the least possible value, and how come there can be more than one value of n? Let's understand these questions. How come there can be more than one value? Well, if let's say a particular factorial is a multiple of 990, all subsequent factors would also be multiples of 990. Let's say 20 factorial is a multiple of 990. So then even 21 factorial will be a multiple of 990, because 21 factorial is nothing but 21 times 20 factorial. Similarly, 22 factorial would be a multiple of 990, and so on. So what we need to figure out is what's the smallest possible value of n such that n factorial is a multiple of 990. Now, in case you're not clear about how to go about it, let's just spend some time thinking about factorials. Let's just start with a small value of n. Let's say 4 factorial. 4 factorial equals 2 times 3 times 4. I skipped the 1 initially, which doesn't matter. So 4 factorial would be a multiple of a 3 and an 8. So 24. That's definitely way smaller than what we need, right? We need a number which is a multiple of 990. 4 factorial is not a multiple of 990. 4 factorial is way smaller than 990. But then what do I notice using this 4 factorial? I notice that 4 factorial would be a multiple of 2, a 3, and then 2 more 2's. So I'm looking at prime numbers now. I'm looking at kind of the prime factorization. For 990, for a number to be a multiple of 990, which all prime factors would n factorial need to have? Basically, n factorial divided by 990 would need to be an integer. When would that happen? When all the factors in 990 get cancelled with numbers within n factorial. Only then would the denominator end up being 1 and we would end up with an integer. So let's look at what are the various factors within 990, the prime factors. 990 can be split into 99 times 10, and then 99 can be split into 9 times 11. 10 is nothing but 2 and 5, 3 is nothing but 3 square. Alright, these are the various prime numbers that are factors of 990. n factorial needs to be a multiple of each of these numbers. n factorial needs to be a multiple of 3 square, it needs to be a multiple of 11, it needs to be a multiple of 2, and it needs to be a multiple of 5. Let me focus on the largest prime number first. What's the largest prime number here? 11. Why the largest? Because if let's say I'm looking at 6 factorial, would 6 factorial be a multiple of 11? There's no way. Why not? Because for a number to be a multiple of a prime number 11, that number needs to have 11 in it. No other two numbers we can multiply and get an 11. 11 is a prime number. No other two integers, right? So for a number to have all these factors, I'm first thinking about the largest prime number, 11. Now, what's the smallest factorial that would have 11 as a factor? 10 factorial would not. Because again, 10 factorial is nothing but 1 times 2 times 3 dot 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 times 10. There's no 11 yet. 11 factorial would be a multiple of 11 because 11 factorial has an 11 in the product. That's a good start. What about 11 factorial now? Would 11 factorial have 3 square in it as well as a factor? In fact, yes, 11 factorial has more than 2 3's. There's a 3 in 3, in 6, 2 3's in 9. So 11 factorial would actually have 4 3's in it. So definitely a multiple of 3 square. What about 2 and 5? Yep, 11 factorial would be a multiple of 2 and of 5. Since 11 factorial is the smallest number that's a multiple of 11, and 11 factorial is a multiple of all the other prime numbers that 990 is made up of, our answer is 11. 11 is the least possible value of n such that n factorial is a multiple of 990.